right. I want to tell you guys a little bit about a major assessment that you're going to have coming up called the Inference Portfolio. And it's going to count as a test grade. It will most likely not be collected until the beginning of the fourth quarter. So most likely it will be the first major summative assessment of the fourth quarter. It's going to count, like I said, as a test grade. And what you're going to do, and I brought in a paper copy here for you. And it's going to be a collection of all 13 tests that we're going to do in this class. We have done one so far. What's the one? We went to the calculator. Remember when we went to stat tests? What option did we pick? Do you remember what it was called? The one proportion. It is option A, but what's it called? Do you know? One proportion. It's the Z interval. Okay, it's a confidence interval for proportions. So that's going to be the first test that you're going to do. And it's not really a test, it's creating an interval. And what I'm going to create for you, or I'm going to give you, is everyone's going to get 13 blank templates. And this is just a template. This is what it looks like. You're going to write the name of the test at the top, and you're going to literally write in what the word problem is, what the context, what the question's asking, and then you're going to do your steps. Okay? You have 13 of these, and I'll give you once this gets copied for everybody, because I just finished it during my planning period. Hopefully you'll get it Wednesday, if not definitely by Friday. You're going to use an example from either our notes in class or a homework example, whatever you choose to do, but you're going to do one example for every single test. Does that make sense? Okay? We're actually going to use an example that we did with the interval last class and do it with a test today, but it needs to be a different contextual example for each one. So you will have a collection of 13 different ones together that you will turn in as a grade. Okay? The one that we're going to do today is the one proportion Z test. Okay, and so it's a little bit different than an interval, and we'll talk about what that means, but you will have 13 total that you will do. Okay? It's a good idea to keep up with it as we go, because you don't want to have to do all 13 at the end. Trust me when I say that. And you want to kind of keep track. If anything, you can at least flag what examples you're going to put into your portfolio. And everyone's can be different. What Josh picks can be different from what Lexi picks, and it should be different from what everybody picks. This is your own collection. Okay? There will be some crossover because of the examples we do in class and whatnot, but you really need to have your own work. This is an individual assignment. Are there any questions about this? I'm going to give it to you, and you want to flag, I'm going to use this example for my one proportion Z interval. I'm going to use this example for my one proportion Z test. You can already decide for number one. What examples have we done? What context problems have we done in class that you could use for number one? The candy hearts, remember the pink hearts, the proportion of pink hearts, that would be an example, sure. What about the Hershey Kisses example? Remember how we tossed a Hershey Kiss and we made confidence interval? What about the globe? We threw about the amount of water on Earth. Any three of those would be fine. You want to look at your notes. All the notes are online as well, right? So you have that as an option. It can also be a homework problem that you did or that we went over, okay? But I will be looking for correct process, context, neatness, that kind of thing, okay? Really what you're doing is you're putting together a study guide for you for inference. Okay, you're going to make sure you check all the conditions for each test. They're going to be listed there for you. What formulas am I using for each test, et cetera, et cetera. So you're really putting together your own study guide. Okay? All right, so this is going to count as a major summative assessment. Again, I will give that with the rubrics and all of that, grade conversions, like how do I get an A, how do I get a B, that kind of thing. You'll get all that next class, hopefully, if it gets copied. All right, so let's talk about what we did. Actually, let's talk about this, okay? There we go. When you read chapter 19, we talked about something called hypothesis testing. And it's different than what we did before. What we did before with the 1 proportion z interval, we used this example, if you remember. Do you remember what the claim was when we Googled, what was the percentage that it said? 71%. And since that's the claim of Google Earth, or what, I forget what geographical society we used or we looked at, then it's the population parameter, right? It's the claim. So what the symbol for that is P. So P equals 0.71. That would be the claim. That would be what the status quo is. Do you remember what we found? We tossed the ball 50 times. How many of those were water bound? Do you remember? But what was the number, though, exactly? 35 out of 50? I think that sounds right. So 35 out of 50, when we toss the ball around, happened to land on water. What is that symbolically? Like, it's not P. What would it be? P hat. Okay, that's the data that we collected. That would be our statistic. Very good. Okay, and we created a 99% confidence interval. What does that relate to? What does that help us decide? If we're creating a confidence interval, we need this information to find what value? The what? But what number in the interval? In the formula, think formula, 99% tells us we're going to find the z star, okay? That helps us find the z star. And do you remember what it is for 99%? 2.5, I think it's 546, isn't it? 2.546, something like that. Okay, good. So this is kind of a refresher. We did this last class. All right, we got some information. Believe it or not, this P and P hat help us when we're actually using a hypothesis test as well. And we're going to use this same example with this same data, and we're going to do it with a hypothesis test. Because sometimes a confidence interval is nice, but it's not convincing evidence enough. Is 71% of the Earth really covered by water? Well, we have an interval that we think is true. 99% of them capture it. But we need some convincing evidence. And a hypothesis test will do that for us. So how many steps did you guys read about in a hypothesis test? Look through your notes. There were 4. Okay? And I want you to look at the notes that you wrote, and I want us to make sure that you have the information listed in each step that you're going to have to write. Okay? So the first step is going to talk about the hypotheses. Okay? How many hypotheses are there going to be? Always. How many hypotheses? There's 1. 2. Okay. Ho. Ha 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 ha. Ho ha. Come on, you guys have to get in with my weird music. It's fine, whatever. All right, anyway. Yes, ho ha. It's our statistic song. Ho hey, whatever. Ho, H-O, H subscript 0 is the what hypothesis? What's it called? The null hypothesis, okay? So this is your null. Smartboard loves to work and loves not to work. The sound made it go nuts. Anyway, it's the null hypothesis. What is HO? I'm sorry, HA? The alternative hypothesis, okay? Whenever we write the null and alternative hypotheses, so this is your null and this is your alternative, okay? They are always, always, always written in terms of the parameter. Always written in terms of the population parameter. Okay? Always. When we look at our earth and water example, what number am I looking at? The 35 out of 50 or the 0.71 or the 2.546? What's the population parameter? The 0.71. That's the claim. So both of these hypotheses will be written in terms of 0.71, okay? So let's actually go for it. Let's write it. We're going to label each step. This is going to be step 1. we are going to write our hypotheses using this context. Not only are your hypotheses written in terms of the population parameter, but you're going to write each twice. You're going to write a mathematical sentence and a contextual sentence for each one. We're going to start with the mathematical part. The claim is, the null hypothesis states that the percent of water on Earth is 71%. The mathematical sentence for that is P equals 0.71. That's the claim. Your null hypothesis almost always will have an equal sign in it. Okay? And it will always be in terms of the population parameter. Since we're talking about proportions, that's P. If we were talking about the other side, we were talking about means, that would be mu. Okay? So this depends on which side we're on. We're dealing with proportions right now, so we're talking about P. What's the context? 71% of Earth is covered by water. So you need to write the mathematical sentence and the context that goes along with it. Both are important. Okay? When we talk about the alternative hypothesis, you have three choices. I'm going to write what those three choices are here. You can either say greater than, less than, or not equal to. And oftentimes they really want us to make that decision before the data's collected. But we can't do that here. So what was our p-hat? What's 35 out of 50? What is that? Is that point what? I don't know. 0.7 exactly? Okay. So are we saying that it's greater than that or less than that? 0.7 is less, right? So why don't we choose for our example here a less than? Because the data we collected was less than. Do you agree? Okay, that's fine. So we're going to say here, we think the proportion of water on Earth is actually less than that. Remember, the numbers in the hypotheses are always the population parameter. Nowhere in there do I have 35 out of 50. Okay? The null and the hypotheses are always in terms of the claim. We're not, that's way at the bottom. Fail to reject, reject, we're going to get there. Okay? We can't reject anything yet. Okay? We believe that less than 71% of Earth is covered by water. Okay? Step one is done. That is all you need to do. Those are your hypotheses. The null is the claim. What are they spouting off? What are they trying to make us believe? We collect some data. We think otherwise. So the alternative hypothesis is what we think is really true compared to what they say. Okay? Any questions so far? Again, mathematical sentence, contextual sentence. Both are essential. We go back to steps. First one's hypotheses. We'll get to rejecting the null and all that in a minute. It really shouldn't be there. It should be in the conclusion part. What does model mean? Look at your notes. What did the book say for step 2? It's the model. We're going to model the situation. What do I need to check for that? Or what do I need to state for that? The conditions and the same thing. The name of the test. What test are we doing? And I'm here to tell you that when I went and graded these AP exams last year and the year before, if you didn't state the test, you went from an E to a P. Just by that one little naming the test. That's picky. They're picky. All right? So that's a really important thing. So I'm including that. You need to still make sure in your notes when you have step 2 under model, you have both of these things. They're both important. State the test and the assumptions or conditions. Assumptions, conditions, same thing. Okay? Important step 2. the only test we know how to do right now? What did I call it at the beginning of the period? The one proportion z-test. So we're going to name it. There we are. We've named it. One proportion z-test. It has the same conditions as the confidence interval that we did. So we have 3 of them. Let's go with what they are. What's the first one? Randomization. Do I know, what can I say about randomization? Well, because we threw a ball around the room in this problem, I'm not sure about random, right? Probably our finger landed on the ball randomly, I would say, but really the purpose is to assume that it is representative. So we're going to assume that our sample is representative. Okay, how about number 2? The independence condition, actually. Success failure is number 3. So what's true about independence here? Do I know that the sample was, each one was independent? Whether Jenna grabbed the ball and had her hand on water, or whether James did it and would it matter? Are they going to be independent of one another? We could also say that 50 would be less than all tosses if we did all, forever. But I think independent samples are fine, okay? So we'll say tosses are independent of each other. And that third condition is the success failure. What's the formula? Byron, what's the formula for the success failure? What's that third condition for proportions? Has to do with an n and a 10. Greater than 10. Yeah. So it's n times what? NP and NQ are both greater than or equal to 10. So we got to check these. Okay. What's n? How many times did we toss the ball? 50. And what was p? What was our success rate? Okay. 0.71 is what we're looking at, right? Isn't that the claim? 0.71? Is that greater than or equal to 10? Same thing with Q. What's Q? If P is 0.71, what's Q? Which would be 0.29. So take a second and check those. Make sure that both of those numbers are greater than 10 today. 71% of 50 is? 35.5, sorry. 35.5, which is definitely greater than or equal to 10. And how about 29% of 50? Okay, so we're good enough, right? We're okay. All of our conditions are met. So our second step is done. We stated the test and checked the conditions. Awesome. What's the third step? Well, if you look at your notes, what do they say? What was the third step? Complete the test. Was there a name for it, I think? Didn't they say mechanics? Okay, so mechanics of the test. There are 2 things you need to find with the mechanics of the test. The test statistic and the p-value. Okay, so the test statistic and the p-value. Both which needs to be done in step 3. So you might want to ask yourself, what's a test statistic? Okay? It's different for every test. Because we're doing the one proportion z-test, the test statistic that we're looking for is a z-score. Okay? And we know a formula for z-score. It was this. Do you remember? But that was when you were talking about means. So how would the formula change for proportions? Well, it's your collected proportion minus the claim divided by the standard deviation, which we know. So it's still the same thing. It's just we're dealing with proportions this time as opposed to means. Okay? Hopefully this is a formula you saw in the reading. Okay? It was definitely in there. And we're going to use it today, and I'm going to show you how to plug it in. Okay? What's a p-value? Let's do one at a time. Should we stick with the test stick first? Let's find that first, okay? So let's figure out in our example, in step 3, what the test statistic is. So I'm going to write the formula just so I have it, so I know what I'm doing. And we're going to find that z-value, okay, that z-score. What's p-hat in our data that when we threw the ball around? What did we find it to be? 0.7, 35 out of 50, right? So I have 0.7 minus. What was the claim? 0.71. And then I'm just going to fill in the bottom. 0.71 was our P. Our Q is 0.29. And what was our N? 50. So to pause the recording, tell me what the z-score is. So we'll say negative 0.1558. Good enough. Okay? Did I expect it to be? I mean, it's less than 1 standard deviation away from the mean. Why does that make sense? That's awesome. The data we collected was very similar to what the claim was, right? The more different, that sounds right. Is that correct English? More different? Differenter? More different? Yeah. The more different that it is, the bigger z-score you're going to have. The further away from the mean you're going to be. Next question is, what's the p-value? Okay, so that's what we need to find next. Look at your notes. I know they defined it. What's the definition of p-value? Someone look at their notes, and what did you say it was according to what the textbook says? Anna, read it for us. Okay, it's the p of, what do you mean the p? The probability, okay? So a p-value is actually a probability, okay? So what is a p-value? It's the probability, which means how do we normally find probabilities? And if we checked our conditions, what distribution can we use to find the probability? I have them hanging on the side of my cart. Now do you know what the ho means? Haha, it doesn't mean ho, ho, ho. It means the null hypothesis. Okay, fine. But we're going to use the normal distribution, right? We're going to use to find the probability. So it's the probability of seeing data like we collected, or something even more extreme, assuming that the null hypothesis is true. Another way to say this in our context would be, how likely is it that if the Earth is really covered by 71% of water, how likely is it that we would get 70% when we toss the ball around? What do you think? Pretty likely or not so likely? Probably likely. So if we think it's likely, what kind of a p-value are we expecting? Probably pretty high, wouldn't you say? If we're trying to say that the null is not true, if we're trying to disprove the null hypothesis, the claim is wrong, what kind of a p-value do we want? Very small. So that's when we get into the idea of rejecting the null or failing to reject the null, and we'll get there in a minute. We want a small p-value. There we go. Okay. How small is small? We'll talk about that in a minute. Okay. The whole point is trying to reject the null hypothesis. Okay. We want to say the claim is false. That's the point of a hypothesis test. We're trying to show that it's wrong. Okay. We want to reject it. But we have to have a small p-value in order to do that. We think in our context, in our example, our p-value is going to be pretty high. Let's see what it is. Okay? So, how do I find the p-value? You told me it was a probability using the normal curve. What goes in the middle of my normal curve? The mean. But don't I have a z-score here? So let's put, if it's normalized, what goes in the middle? 0. Where does the z-score? It's negative 0.156. How do I know which direction to shade? It's best based on the alternative hypothesis. Because the alternative hypothesis is less than, how are we going to shade? We're going to shade less than. The null hypothesis tells us how to shade. How do I find that probability? Normal CDF. What's my lower bound? Some negative number far off to the left. Negative E99. Since its z-score is negative 10 is probably enough. What's the upper bound? Negative 0.156, or negative, we should probably not round very much. Since it's z-scores, what's the mean? And then the standard deviation would be 1. Tell me what the p-value is. I got 0.438. Try again. Double check. Did you get that? Okay. So we have a 44% likely chance that our data is going to be that. Okay? We want a small p-value. Is it small? No. How small is small? Well, it has to do with your confidence level. Okay? In this problem, when we did our confidence interval last class, what was the percent of confidence that we used? 99%. That means the alpha level, okay, alpha is what you compare. Did you hear about alpha level? Did you read about it when you read the book? Talked about alpha? You know what that is? Your significance level, okay? Means the significance level. And it's going to be the complement of this. So what would the significance level be? It'd be 0.01. Because 99.99 and 0.01 add together to be 1, okay? So they're tied together. You're going to compare your p-value to your alpha level. Your probability, the likelihood of our sample happening, compared to the significance level, okay? Waiting for the, there we go. Strange. Maybe, it's red again. Oh, never mind, it's back. Okay. So what we're going to do in our hypothesis test is we're going to be using an alpha of 0.01 because that's what we use with our confidence interval, okay? So this is step 4. This is our conclusion. Step 3 was your test statistic and p-value. We found both of those. Step 4 is your conclusion. There are 3 parts to your conclusion. You have to mathematically show me what's happening between our p-value and our alpha level. In this case, it was much bigger, right? So we're going to say 0.438 is bigger than 0.01. I need that mathematical sentence to be there. Show me that you are physically comparing your p-value to your significance level. It's very important. It's always part of the AP rubric. Okay? Show that. That's first part of the conclusion. The second part is either to reject the null or to fail to reject the null. Okay, and believe it or not, that semantics is what they want you to say. I want a small p-value so I can reject the null. Do I have a small p-value here? No. I can't reject it. I can't say the null is wrong. Based on the evidence I have, we have to say that it might be true, right? We can't reject it. We never accept it. We never say, it's definitely right, because that's statistically uncomfortable for people. But we're going to say that we fail to reject the null here. Our p-value was not small enough. We would need something like 0.004. We need a very small p-value in order to reject the null hypothesis. So we have step part A, part B, and our conclusion. And part C, what do you think you're going to have to write for part C? A sentence conclusion. Okay? In context. So we've compared our P to our alpha. We're failing to reject our null. Our conclusion is we do not have evidence. We'll say we do not have sufficient evidence to say that the percentage of water, of the earth covered by water is less than 71. Okay? We don't have evidence to say that. We tried, but our data we collected was just too close to it. Wasn't far enough away. Believe it or not, that my block 2 had 60%. They had 0.6 as their p-hat, and it still wasn't big enough. Or still wasn't far enough away to reject. Okay? So, in your hypothesis test, all 4 steps. Okay? Do we know what each step is looking for? We know how to find it. I'd like to do another one. Okay? This is actually the one from your textbook. Okay, so if you've written this one down in your notes already, you don't have anything else to write. You're okay. This is the exact one from the book. If you didn't, then we should probably write it down. Okay? So I want you to go ahead and do 4 steps. All 4. Okay? First one, I'm going to stop and pause. You're going to do step 1 first. Write your context. Write your hypotheses. The information you want to pull out of the problem, you want to pull out your P. By the way, there's too many darn P's in this. There's P, P-value, P-hat. It drives me nuts. And I don't know why they can't pick a different letter, but they don't. Sorry. Okay? But please make sure you know the difference between the P, the parameter, the P-hat, which is your sample you collect, and the P-value, which is the probability. They're 3 different things. But you want to find your P and your P-hat. And you want to find a word that tells me the direction of my alternative hypothesis. So, question. You're not going to the bathroom right now. Okay? 80%. What's that? Well, this is an emergency. If it's an emergency, go. But if it's not an emergency, you filled your water bottle up right before class. 80%. What we got? What do you think? Is that P, P-hat? What is that? That's your claim, right? That's your P. Perfect. So that's 0.8. Let's keep going. What's 90? N. Very good. And N is always in the bottom of your P-hat, right? What's 68? What's 68? Hello? What's 68? What's your other number? Is that a numerator of your p hat? Isn't 68 out of 90 what they're talking about? Right? So you've got your numbers. What's my null hypothesis? What letters am I putting in it? Z, Z star, P, P hat, mu, X bar. What letter goes in there? P. It's your parameter. P equals. What does P equal? 0.8. That's the claim. You better write a sentence. What's the context? 80% of people pass their driver's test. The DMV claims 80% of the people pass the driver's test, right? I'm looking for clue or keywords in the problem that will help me write my alternative hypotheses. Okay? What's my alternative hypotheses? What's a keyword in the problem that will help me write it? Lower. Lower than is my keyword, or key phrase, I guess. Okay? It might say greater than. But that is exactly what it is we're looking at. Lower than tells me that I'm looking at lower than 0.8. Okay? This lower than right here corresponds to that lower than. So the words that would help me write it, lower than, greater than. What was the third option I told you? Not equal to. What would a keyword be in the sentence that would say not equal to? It wouldn't say not equal to, probably. Is not the same, different than. Different could be a keyword that would say, that would imply not equal to. Okay? But you're looking for something in the problem that tells me how to write it. Fair enough? All right. I'm going to pause the recording, have you guys check the conditions for step 2. Don't forget to state your test. So 1 proportion z-test. What do I say for condition 1? It says in the problem they were randomly selected, right? So we're covered. So the sample was collected randomly. I don't have to worry about representative. It says randomly. All right. Step 2. I don't know if they are or not. Maybe. But we definitely know that 90 is going to be less than 10% of all drivers, don't you think? So let's do that. We know that for sure. And then how about NP and NQ? So N was 90. What's P? 80%, isn't it? And then Q would be 20%. What's 80% of 90? 72? That's greater than 10. By the way, just mathematically, both of these numbers that I'm getting ready to write should add up to be 90. So this should be 18. Is it? It is, though. That's the way it works. So it should add up to be your N. They're both greater than 10. So our conditions are met. Hallelujah. Step 3. I really am going to ask that you write the formula that is used to find your test statistic, okay? They really are very particular about naming your test and using the correct formulas. So what's the test statistic that I'm finding with that we have here? The z-score. So I'm going to write the formula for the z-score. I'm going to write it pretty, though. Yeah, so we did that up in step 2. So you should do both. What's the numerator? Hello. P hat minus P, right? Okay. And we're going to plug in our numbers. So let's plug them in. 68 out of 90. I don't think that's an exact,
0.75.
yeah, 0.7 and then 5 repeats. So we really should be putting in it as a fraction. Don't round that, okay? So leave it as 68 over 90. Minus 0.8 was the claim. Good. And then we have 0.8 times 0.2, because we have our P and our Q, over N, and N was 90. Tell me what the z-scar is. And we'll do the shortcut in a minute. All right, so step 3, am I done with step 3? I found my z-score. I found my test statistic. Done? No. What do I have to find next? P-value. And I really want you to draw it. Since we're talking about a z-score, I mean, I could put the mean of 0.8 and then put 0.755 and shade less than. But since we already have the z-score, we're just going to use it, okay? And so we're here. How did I know to shade to the left? Because the alternative hypothesis said less than, okay? So we're good. And so we're going to do normal CDF, lower bound, upper bound, mean, and standard deviation. And the p-value I got was 0.1459. Yeah, this p-value is still too high. The problem is, what do I compare it to? My alpha. Before, when we looked at alpha, we looked at the confidence interval. It was a 99% confidence interval. I don't have a stated alpha here. I don't have a confidence level or a significance level here. Well, you could choose, but there really is kind of a fallback that we always use. And it's 0.05, 95%. Okay, so 0.05 would be our fallback significance level. Okay, so for our last step, we are going to use, since there wasn't one stated in the problem, we'll just assume it to be 0.05, kind of like a 95% confidence interval. Okay, so we're going to compare our p-value. It happens to be bigger than alpha, because 0.1459 is bigger than 0.05. So I have my mathematical sentence. What now? We can't reject the null. It's too big. It's not less than. So darn it. So we're going to have to fail to reject the null again. And what's my conclusion in context? Got to write all 3 for step 4. We do not have enough evidence to support that what was the context of this problem? Percent of drivers, right? So we do not have enough evidence. The reporter in the problem collected data and said it had to be less than based on his sample, but based on the test, it's not low enough. We do not have enough evidence to suggest that the percent of drivers who pass, say, a passing driver's test, is less than 80%. We just don't have any evidence to say that. It's not less. Okay? Our p-value wasn't high enough. It's a lot of work. If I look at this whole thing, all of this is one hypothesis test. Okay? So when you put together your portfolio, notice how I have the name of the test, the problem, and I have it broken into 4 pieces. So I want you to show me all the steps. Okay? So that'll be there for you. I'm going to show you the shortcut on the calculator. Oh, yeah, So if you don't have a calculator now, get one, but you're going to need one. Okay? Let's look at, on the calculator, where we would go to find our test. Now, the shortcut on the calculator does not omit you from any step. The only thing it's going to do for you is make sure you shaded right, drew your normal curve right and shaded it. Did you find the correct p-value, and did you find the correct test statistic? But I still need you to write the formulas. Okay, so you're not omitted from that. It's basically just checking, did I get the right answers? The calculator is going to give you this value and give you this value, okay, without the calculations, but I need to see the work on how to get it. Fair enough? So just waiting for you to check your answer. So where do we go to do the interval on the calculator? Do you remember? Stat, tests. So that's where we're going to go again. We're going to turn our calculator on, maybe. There we go. Stat and over to tests. The interval was option A, the 1 proportion z interval. We want to do the 1 proportion z test, and that's option 5. Stat tests, and then 1 proportion z test. It's going to ask us some information. That P0 is your claim, okay? What is the claim? What was the claim of the percent of drivers who passed? 80%, so we're going to put 0.8 here. And then when the newspaper reporter went and collected the data, wasn't it 68 out of 90? So that's what we're going to put here, 68 out of 90. Notice in the next step on the calculator, it's giving you your 3 options. Is it greater than, less than, or not equal to? And we did less than, didn't we? So we're going to go and choose less than. Calculate and draw will give you the same information, but draw will actually draw the normal curve to make sure you did it right. So I kind of like the draw option. So that's what I want you to do. Oh, except for mine has other things on it. Like if you go to your y equals and you have junk in there, like I have my stat plot turned on, so it's trying to graph the stat plot on there too. Just go back and do it again. So stat tests. I'm just making sure there's nothing else in there, and then it won't draw everything else on there. Like if you ever get an error, it's because you have something in your y equals. Oh, notice what not equal to looks like. It's a two-tailed test, okay? And we're going to talk about that, what that is in a minute. But yeah, sorry. We did a one-tailed test. Thank you. So we want it to be, I think the default is actually a two-tailed. But here we go. So I did less than. We have a shaded graph. It looks like my shaded graph. Notice my z-score, same that I found by hand. My p-value, same that I found by hand. Okay? So we know we did it right. Woohoo! We're smart. Okay? So what would be different in the problem if it was a two-tailed test? What would make this a two-tailed test? Or a not equal to test? What word? Only one word would be different, or 2 words would be different. The question is, this is now a less than test, a lower than. What word would be in the problem to make it a not equal to? Different. It might say not equal to. Okay? But I would change this word from lower than to be not equal to. So lower than would now become not equal to, or different. Okay? So it's going to say different. Your alternative hypothesis is the only thing that changes in the beginning. Your null hypothesis was P equals 0.8. It stays. That doesn't change. But my alternative now becomes P is not equal to 0.8. Okay? That in and of itself makes it a two-tailed test. The name doesn't change. The conditions don't change. As a matter of fact, the z-score, the test statistic, doesn't change. The only thing that changes from here on out is the p-value. If it's not equal to, that means it's not less than, nor is it greater than. So when I do a two-tailed test, it's going to look like this. Notice the symmetric. If it's negative, it becomes positive. And we look at this. How would I take my p-value? It was 0.1458. That was just the less than. If it's a two-tailed test, what would I do to that p-value? Multiply it by 2. And according to the calculator, if I do that, my p-value is now going to be 0.2918. Hopefully, that's what 2 times that is. And it should be. Okay? Still big p-value, wouldn't you agree? Really big. So what am I still going to do? Fail to reject the null. I can't reject it. It's not small enough. So I'm still going to keep it so it has the same outcome as it did before. Okay? All right, I would like for you, I'm going to stop the recording because it takes too long to confirm. I am going to give you your homework, but I am going to give you one more to try it. I want you to try it in class, okay? But I'll pull that up. But I'm going to stop the recording first after I give you your homework. It is chapter 19. It's page 511 to page 514. Problems 2, 4, 11, 14, 16, and 21. The last 3 are full hypotheses tests. Would you like to try one in class? Which one should I pull up? The even one? The one where the answers aren't in the back of the book? Okay. So I'll pull that up. Okay? So I'll put it up on the board.